Kathy is here. Kathy Whitbroad has spoken on behalf of ARIN at previous NANOG meetings and spoken on other topics at NANOG. She's a former colleague at Merit, and here she is.
Howdy. See if I can find my slides. There they are. So I have to go back to the beginning. Hold on. In my fine tradition of giving other people's presentations, that's what I'll be doing today. So neither of these are actually my work, and I don't know very much about IPv6, but but I found these presentations. Well, the first presentation is an update on what the RIRs, the regional registries, how they are assigning v6, how many blocks have been assigned. And the second presentation is by a guy whose name I can't pronounce, but I hear it's something like Hert. And I don't really know him, but I heard him give this talk at a meeting in Europe, and he doesn't have a travel budget. And I thought it was really interesting, so I traveled the world giving his presentation. And anyway, it's really interesting stuff. There is a global v6 routing table, believe it or not. So let's start. So anyway, that's what I just said, so I'll skip that. I don't know if you can read these, but I found these with the help of some other people, and these are actually really interesting websites that have different characterizations of the global v6 routing table. And one of them in particular is like this holistic view, and it's visual, and you can look at who announced what and which prefix. It's really kind of neat. So if you get a chance and you're at all interested, they're really neat websites. And maybe we should do some of this stuff with v4. It might be kind of cool. So this is a presentation that Ray Polzak put together about the IPv6 address allocation process and policy and all that good stuff. So a little bit of history. Let's see. In 1999, we had an interim policy. And what people don't really know is that pretty much anybody could get a block. Too bad you didn't. We went through a lot of processes to try to have a global kind of a uniform policy across the regional registries. And we got a joint consensus in May 2002 on a new initial policy, and I'll talk about that some more. It's really, really hard to get consensus among 3 different geographic regions, now 4 because of LACNIC, and all the different meetings scheduled at different times. It's pretty interesting. So some of you may be familiar with this, some of you might not. This is what the address space used to look like and what the things used to be called, and the bit boundaries, and TLAs and sub-TLAs, and as Ray has graciously animated, that went away. So we won't talk about that. I don't know if Tony's tutorial talked about this yesterday, but it'll be quick if it's redundant. So the new breakdown of the address space kind of, is it going to do anything? Hold on. Okay, so I can't tell whether it's going to keep going or whether it's going to stop. Okay, so an N-site assignment based on RFC 3177 is /48, which if you do the math is a really huge amount of address space, but everybody wants more. And the minimum allocation that the registries give out, so in V4 it's a /20, and V6 it was a /35, but that just got relaxed. So folks who have a /35 already, they can get a /32 by just asking, get it the boundary flipped over. And if you go and you meet the criteria, which I'll talk about some more, then you can get a /32, which is way bigger than a /32 in V4. And then there's a proposal underway. Right now the regional registries go to IANA or ICANN, and they get a /23, right? They get a /23 that they then allocate out like they do with V4. And what they want to do is get a /3 that's a pool that's used among the regional registries so that they can do more smart allocation and spacing out different, different allocations so that they can grow and be contiguous. So that's a proposal that's being tossed around. And if you have questions about that, you can ask Richard Jimerson, richardj@arin.net. So how do the assignments work? The usual end site size, like I said, is a /48. A /64 is what you would assign as an ISP to a customer if they have only one subnet and they swear they're never going to subnet again. And if you have a device connecting like a cable or a dial-up subscriber or whatever, they get one address, which is a /128. And then the other assignments that happen are in ISP infrastructure. You give out a /48 per POP. And this is part of RFC 3177 as well. So how does it happen? How do you get an initial allocation? So most of you, I guess, well, at least in theory, are ISPs. So if you wanted v6 address space, you would go to a registry and you would get it, just like you do with v4. And this is the process that happens. That's a flow chart. I love flow charts. So if you need an address, you're going to get a lot of them if you need one. So if you meet the allocation criteria, which is there on the screen, you're not an end site, you must be an ISP. In the RIPE region and the other regions, they call them LIRs, which are local internet registries, which is basically their concept of an ISP, but it's a little bit, anyway, that's what it means. It's the same thing. And if you plan to provide IPv6 connectivity, and you're going to have 200 end sites connected to you within 2 years, and then if you meet those criteria, then you can apply for address space and sign the agreement and pay the fee, and then you receive your /32, which is the minimum allocation. Sorry about my voice. So if you use up that huge amount of address space that you get, which I can't imagine you would, but if you did, then you could go back and get more, and basically you'd apply again and you'd justify another block, and you'd get another /32, or they'd move it 1 bit, so you'd get a 31. So let's look a little bit at what's been allocated. In v4 space, the numbers 17, 9, 9, 111, those are /8s, right, Richard? Okay. This is what's been done in v4, just for comparison. The most notable thing is that the assignments per registry in v4, ARIN has assigned quite a bit more than APNIC and RIPE. But if you look at the v6 allocations, you'll see that APNIC and RIPE are certainly assigning a lot more v6. And actually, if any of you have any ideas why that's so, or I'd like to hear from people about why you're not doing v6, or because it seems to be a really the thing to do in other outside the U.S. So anyway, this is the breakdown of the numbers after the 29, 62, 63. Those are actually allocations to ISPs. So those would be the /32s that have been handed out. And then this is a graph over time. And then this is a breakdown per country of, and the numbers by the countries again are the /32s or /35s, depending on whether they've come back to get their 32. So this is what it looks like. So there's a lot in Japan, and certainly, all the other little slices combined, certainly, pretty large. And that's the end of the v6 registry report. Should I take questions in the middle, or does anybody have any comments or questions? Okay. I didn't think so, because, I don't know, it doesn't seem like, let's see. So this is not in English, just to see if you're awake. The last time Kurt presented this was in the RIPE meeting in Greece, I believe, so I think that maybe this might be Greek. But I couldn't figure out, he has them in this HTML thing with an index, and I couldn't figure out how to delete this slide without screwing up the index, so I left it. This is what it really says. And I have his email address later on if you're interested in asking him questions, because I may not be able to answer your questions. But again, I heard him present this talk at a RIPE meeting quite a while ago, and I was kind of thought it was neat that there was a global v6 routing table, and some of the stuff that actually happens in the v6 routing table is pretty entertaining, so I thought that this audience would really appreciate it. So what is it? Well, it's a bunch of different ISPs exchanging routes, and we have some pictures and observations, and some of them are pretty cool. So the V6 routing table contains a mixture of 6-bone address space, which is historical. And and another comment about the 6-bone address space. It's actually, since the last NANOG I was at, there've been a lot of discussions, and it looks like the regional registries are actually going to take over the allocation and maintenance of the 6-bone address space, which is a really kind of a neat thing. So it's a mixture of the newly allocated RIR blocks and the 6-bone blocks, and I have a whole bunch of graphs of how that's broken down. Some ASs announced the 6-bone stuff only, and there's a mixture, and some of them advertise RIR space only. I think it depends on what you got, because if you have one block, you really don't need another one unless you're transitioning. The infrastructure is a little different from region to region. The really interesting things for this group are that, unlike in V4, pretty much everybody's giving transit to everybody else, and it could be that that changes over time. But I think in the spirit of getting the new protocol working and getting everybody happy and cooperating and stuff, they're actually just, it's like in the old days where if you peered, you got everybody's routes from everybody. There's not a lot of filtering going on, as you'll see, which is pretty entertaining. And there's still a lot of tunnels, but the tunnels are being phased out. So I'll talk some more about that. So the way this chart should be read is on the left, there's the length prefix. And then if you look at the column all the way over on the right, that's what the same numbers were on April 28th, the last time you ran the numbers. So on, September 9th, there were 374 prefixes in the global V6 routing table, and on April 28th, there were 297, and this is the breakdown. So as you can see, there are a lot of 35s and 32s because those are the minimum allocations. There's a lot of /48s, which says a lot about, people advertising more specifics, and there's a couple /128s, which is kind of cool. I don't know whether people will start filtering in the long run, but this is mostly because nobody's filtering. So this is what the growth looks like for the last 12 months, and this is all the prefixes, whether they're RIR or 6-bone. And some of these little peaks, or big peaks, there's some breakdowns of what they are, so I'll talk about those. And this is a comparison of the top line. Well, in the beginning, the top line is the 6-bone space, and the bottom line is the RIR space. And what's interesting is they're starting to cross. The RIR prefixes are starting to grow beyond the, more than the 6-bone prefixes. So it seems like, that natural process of the RIRs assigning the space and the 6-bone not is starting to happen there toward the end. Let's see. So there's about 200 and some prefixes, depending on who deaggregated what day, and then reaggregated again. Excuse me. So these are a couple of the little blips. So on the left, you can see that somebody deaggregated 60/48 out of 6-bone space. The AS number's there, so you can look it up if you want. And there's another one where somebody leaked 37 more specifics. So that happens a lot. Sometimes, as you can see, they usually get deaggregated again. It's just somebody who didn't filter right. This is interesting because, the policy change from 35 to 32s happened 7/01. So what is that? July 1st. And so you can see that the 32s are growing and the 35s are starting to get aggregated and disappear from the routing table, which makes some really interesting artifacts that I'll show you in a couple minutes. Let's see. The 624 prefixes, and I don't know a lot about this, but it looks like there's some being advertised. I think that's the point of this slide, is that these are the ones that are advertising the AS numbers. And there's some more information on any cast addresses and RFCs are listed. So if you're interested, you can take a look at that. Let's see. So in the summary, there's 144 allocations out of the 2001 block that are being announced. and 201 allocations by the RIRs. And here's the breakdown. And the number in parentheses is the number that was the last time he did this, which was 4/31/2002. So ARIN's grown a little bit, and if you look, you can see that APNIC and RIPE have grown quite a bit since April. There are 144 allocations visible, but only 161 routes, and that's the breakdown of the prefix lengths. And some of them are still advertising, as we saw in that graph, 32s and 35s at the same time, which kind of makes sense for transitioning. There's 241 unique ASs, which has grown, and RIPE and APNIC have both gotten new /23s. So ARIN's still assigning out of their initial one. RIPE and APNIC have just gotten new ones, which is, it means that there's a lot getting handed out. This is a breakdown of new /32s and /35s. Let's see, and the ones with the star by them, Garrett said were seen sometime between May and September, but then not anymore after September 10th. So those are prefixes that have been withdrawn because of less specific /32s. The IXs are exchange point blocks. I think there's one, 7F8. And I'll show you there's some ghost problems, excuse me, in the routing table because of the /35 withdrawals. And if there are any router vendors in the room that have any idea, or people who have any idea why, contacting Garrett would be pretty useful, because he's been trying to track this down for a while. So this is the interesting thing that happens when you start advertising the 32 and you withdraw the 35. You end up with these ghost announcements with these really nice AS paths, really short, concise AS paths that seem to stay around for a really long period of time, even though they don't really resemble the AS path of the originally announced /35, as you can see. And this happens a lot, and they'll be there for months. So there's some theories, but nobody's really figured out why this happens. There's a lot of prefixes in the table that actually aren't prefixes at all, or are out of blocks that shouldn't be advertised, and here's a few of those. I think the bottom one is another one with the really long AS path that was advertised correctly and then pulled out of the routing table, and it stayed around for, what did he say, 2 months with this really long AS path. So that's kind of cool. Let's see. There's a lot of lazy aggregation going on where people just say, oh, well, nobody's filtering, and I'll just announce whatever. And so there's these /128s in the global routing table, which are pretty cool. I'm sure that that'll be great when we have lots of people doing v6. It looks like there's some multi-homing going on where people are announcing more specifics to multi-home, and there's still no really defined practice. If anybody in here is on the multi-6 mailing list, you'll see that there are lots of interesting ideas for how we would multi-home, and nobody is agreeing on any of them. So that's a real concern, I think, with v6, because we could have really large routing table. Let's see. Invalid AS numbers are pretty cool. So there's several people announcing ones that shouldn't be announced, and ones that aren't assigned, like 45.328 isn't assigned, but it's in the routing table, which is kind of neat. Let's see, I don't know what else. Let's see. I like this one. I like the It's All Mine slide. Somebody had a bug. I guess it was a bug in Zebra, so they announced a lot of the v6 space that wasn't theirs and decided that it was all theirs, so that was kind of cool. The good news, more people are peering natively with v6, and the tunnels are starting to go away, which is really nice. Let's see. They're doing smarter things over the tunnels with BGP metrics. People have started filtering for obvious reasons from the previous slides. It's kind of probably a good thing. Usually what happens is people accept everything so that they can get everywhere, but they're conscientious about what they re-advertise to their peers, which is kind of polite. And here's a really nice prefix filter if you're interested in filtering. And there's some more filter stuff on here, webpage, so if you're interested, you can take a look at that. Hope my voice holds out. So these are, oh, that's a good idea. These aren't my slides, so I have no empirical proof of my own that it works, but I've heard it does. I have a funny story, though. I went to this workshop where we hooked up V6 and network with the guys in the room. There were like, I don't know, half a dozen of us or so. And I have this iBook, and it's running OS 10, and I loaded Zebra on it because I heard Zebra did V6, and I went off to this meeting, and I spent half the morning looking on the web page trying to find some way to configure V6 on my laptop, which was futile because nobody at Apple has any, you know, I mean, like the customer support people, the man pages have no idea. And so I thought, well, you know, we got the router working, and it was happily doling out addresses, and so I did an ifconfig, and sure enough, I'd learned my address, and it all just worked. It was pretty scary. So I had wasted like 4 hours reading documentation when it just worked, so that was kind of cool. Although I did learn that subnetting these addresses is just really evil, but you can spell things in the, you know, like dead. And so every group in the room got more creative about what words they could spell. So I'm waiting to see somebody do a little subnetting tool that lets you pick what words you want in your addresses. So when you give them to somebody you don't like, you can write something in the address. That's pretty cool. So the stability, apparently, from their point of view, has gotten better. Their software problems are getting better, like that guy who advertised everything was actually a bug. And the transit, it sounds like, you know, with everything, that when people start making money, they stop giving transit. So if you want V6 transit, maybe you should start peering now, because you might not get it soon. And filtering is recommended, and, you know, certainly it makes sense to watch out, see what people are advertising. And they're starting to consider getting rid of the guys doing the bad stuff, although it doesn't seem like there are a lot of them. I'm just curious, how many people here are doing V6? Not very many. Huh? Why would they do it, or why shouldn't they do it? Why are you doing it? Do you have customers? Does anybody have a paying customer that uses V6? Wow, 2. That's cool. Well, I think that, oh, and here's some little other things to look at. And again, the URLs I had at the beginning are really pretty interesting. If you're into like looking at the routing table, they're pretty neat. I think that's the end of my incredibly short presentation. Does anybody want to give any feedback about why they think that, you know, the other, I mean, I know that my take on it is that in other countries, you know, they didn't get as much V4, so, you know, you can get a lot of V6. And, you know, there's a lot of, you know, cellular phone companies and stuff that are really keen on having enough address space to do what they want to do. But it seems like, you know, we're a lot, oh, Avi's coming to the microphone, how exciting. We'll see what Avi has to say. Or is he just walking by?
The Peanut Gallery has suggested that most of the countries, or at least made the observation that most of the countries where IPv6 has been in heavy use, the engineers get 5 weeks a year of vacation, and so they have plenty of time to play with new technology, you know. But
they do it on their vacation?
I don't know, maybe. Who knows? We assume that they have good work ethic. They just get 5 weeks of vacation because they live in those countries. So, but, you know, seriously, I was talking with one of the evil government people who was here on Monday, and what should the government strategy for IPv6 be? And I said, it seems really simple. It's like the NewNet thing, right? Until there are content providers who are only accessible on it, or end users who are only accessible on it, or we actually run out of IP space, which we're not about to do in the next foreseeable, you know, couple of years, it just isn't that much of a priority for people who are pretty overworked. That's what I see from the people, you know, that I deal with. So the simple lazy American answer isn't very relevant yet because no one wants to pay for it and there's no crisis.
Oh, that makes sense.
I just followed that. For those who were at the tutorial the other night, you heard this, but, you know, so I apologize for being redundant. I was just in Shanghai in August, and at an education conference, and the education network manager told me he could use 72/8s if he could get them, right? And
So could I.
to build out his network. And then over dinner we were talking. He's got 320 million students to support, right? If you look at the population of North America, it's under 300 million. So I went and did a back of the napkin calculation, and ARIN manages about 75/8s. That don't count Department of Defense or anything like that. So, he's in the ballpark for what we use currently, right, for the population he wants to support. So effectively, we're gone. It's all gone already because there's only 90 left, right?
Anybody else? Oh, Stephen. Yes, sir.
Hello, my name is Stephen, and I use IPv6.
Hi, Stephen.
I will confess to having gotten involved with it when I was a researcher, and it was a fun science fair experiment. Since then, I have fallen in with an even worse crowd.
Oh, no.
And one of the hats that I wear, I'm expected to provide infrastructure that will operate in IPv6 land. And so, not wanting to function in the vacuum that I learned was so comfortable in research, we have a presence. We're out there on the net. We're doing all the same things that the people who would be developing, revenue-producing infrastructure would be doing, because we eventually, we support them. In my day job, my customers expect that I'm, in the same way that I provide, V4 exchange point services, that I'm going to provide V6 exchange point services. And at least there's not really any rocket science. I move Ethernet frames for a living. And so if the ether type is 800 versus whatever the ether type is for IPv6 frames, 6.5 doesn't the other to me. I just need to dole out exchange point addresses like I do for V4, but then have some clue to be able to answer questions when people have trouble getting V6 working, or they wonder why they see certain types of announcements on the exchange point prefix. They ask me, and I say, no, that's wrong, and I go, educate whoever is sending, router announcements or what have you. So that's my thing.
All right.
I feel
better?
I feel good. I feel better than.
Thank you, Stephen. Everybody, support.
What a nice experience. I have a question. I work for a carrier now, but before that, that's like one of those things too, isn't it? I work for a carrier. I had some experience trying to get a technology pushed out into the internet in the past, and I kind of come to the point, like, the reason I asked my question to Tony is, it seems like when there's a desire and a need for something, the internet community really mobilizes well, and
Oh, I see.
so if there is this huge, the carrier thing is kind of instructive to me, because the carrier I work for happens to have a cellular arm, and so we hear a lot of
Really?
this. Well, yeah. Well, I think so. I don't use it, but I think it does. I've tried anyway. So I don't fully understand what the problem is with IPv6. If there's this huge demand for address space, because apparently, based on what Tony was saying, maybe that's what's driving things. If that's there, why aren't there business models? Why aren't these things happening? And is there anything we can learn from our past experience that will be instructive as to why this is happening this way?
Maybe
Good statement. To follow on some of the things we'll talk about next time, more detail, but one of the issues is, you as a community are not going to go out and deploy a bunch of stuff unless you see customers demanding it, right? And IP, by its nature, is not something your customers are aware of per se. They want packets to move, right? They've got an application. You happen to know it needs IP underneath it, but they probably don't. And in particular for consumers, if we've made it so that the consumer knows that you're using V6 instead of V4, something's really screwed up, right? Consumers shouldn't ever see the difference. All they know is they type a name or click on a link and magic happens, right? So what you're going to get is an implicit demand. If you start looking at your network and you start seeing a lot of protocol type 41 packets flying around, that's implicit demand from your customers that they want V6, right? Because what we've done is made it so that this technology is deployable independent of the routing fabric, where some of the other technologies required you to move them in conjunction. So this one, we've decoupled it as much as possible, and you can get this implicit demand. So when are you going to start seeing that implicit demand? That's the leading question, and it's a hard prediction. But certainly Microsoft has already started telling their development partners that this is important as far as they're concerned. It's embedded in XP. It's coming in .NET Server with application support.
It works on my Mac.
It works on the Mac. Sony is pushing hard into this space. You're seeing a lot of Japanese service providers turning it on and new applications coming from that area. So when's it going to actually hit? I can't tell you, but sometime over the next couple of years there will be a lot of implicit V6 going on because it's just going to tunnel.
Just one comment on that. A lot of our customers are ISPs, and there is an artifact that's visible to them, and that's the address space issue. So it's not that they don't know. A lot of them are asking for, I've heard a lot of people ask for V6 based on that as the artifact that's of value to them. Mm-hmm. So it's not that customers don't see it, end users don't see it maybe, and I think that's what you meant, right?
Right.
But customers do see it, especially in the case of carriers where a lot of their customers are ISPs, and a lot of their problem has to do with, I can't get address space, I can't remember all of this other stuff.
One of the proposals I heard from somebody who I'll let him remain anonymous was that maybe what they would do as an ISP would be to tell the customers, well, if you want another V4 address for your house, then you pay $5 or whatever. But if you want to switch to V6, you can have this big huge block and never have to talk to me again for free.
Why would I do that? What would be my business advantage in doing that? Because I would actually have to provide that facility now. Now, why would I do that?
Well, I can tell you who proposed it later, and then you can talk to him.
No,
I don't really.
Okay, if there's a reason, no, I'm just wondering. It doesn't really. It doesn't. It would go the other way, I would imagine.
Well, I think that it was his way of trying to move V6 forward. Stephen?
/64s for the masses give a powerful incentive to the virus authors to not even bother spoofing for unicast RPF checks.
Second straight man. Last night in the security BOF, the discussion about unicast RPF came up. And since we have a much larger group today, I'll re-ask the question. Given that the way unicast RPF needs to work to be very effective and pushed all the way out to the edge, it needs to be the default setting for everything, right? But when I go and tell the product teams that they need to do this as a default in all cases, they come back and say, but the customers are telling me that they don't want strict unicast RPF because it doesn't work if I'm a multi-home thing, right? And so this community, having the clue, I contend, has the ability to turn it off. But the people you really need to have it turned on don't have the clue to turn it on, so we need to turn it on by default, right? And so I asked the question last night, how many people would want it on by default? Everybody raised their hand, and then they immediately said, but I don't want it to apply to me. Right? So there is a cost trade-off here. So my point to the community is, if you believe unicast RPF at the very edge where it does the most good is effective, you need to tell your vendors this and be very clear and be willing to step up and turn it off if it doesn't apply to you, right? Because that's the thing that's actually going to be cheaper in the long run, to solve this. But you do have a point. Spoofing within the 64-bit space, they can do a lot of damage there, quotes, right? But you allocated that 64-bit subnet to that customer, therefore you can track it to the customer, and they can be, whichever host in that space, but you're still that customer.
And I Right, and I hope it's /64s within their infrastructure, and that they don't then have to fan it out to, you know, a whole bunch of /112s or something.
Well, if they're going to try to do fanouts, you give them 48s, right? And that way, they're getting 64s and you could track it to the subnet.
So I have a story similar to the Mac story, except I had a pile of iron from some unnamed router vendor and had put it all, glued it all together with ISIS as my IGP, and I assigned a couple of IPv6 addresses, and lo and behold, it just worked. All of a sudden, my V6 routing table was populated,
That's pretty
and
amazing.
I didn't do anything.
It's magic. Not really, but it sounded good. Anyway, anybody else, or are we done? Great, thanks.